Hello everyone, welcome to Code Guide, and today we'll discuss the topic BERT, and we'll also see the implementation part. In the presentation part, we'll see the important topics like definition, the working, how BERT learns, the need for BERT variants, the different types of BERT models available, and let's start. So starting with the definition, BERT is basically it stands for Bidirectional Encoder Representation from Transformers, and it is a language model developed by Google AI in 2018 that helps machine understand human language better and in context. So as per the definition, it revolutionized NLP by understanding words based on their full context, words before and after. Now it pre-trained on massive text dataset, allowing it to be fine-tuned for various special NLP tasks with higher accuracy. So for various NLP tasks like classification, sentiment analysis, we can use this BERT model, and we can also fine tune this model according to our data set so that we get higher accuracy with this model. Now, how BERT learns? The core ideas we'll understand. First of all, it learns by predicting the randomly hidden, that is the marked word in sentences using the surrounding unmarked word. So in case of marking, we basically hides the words in the sentences, but that is the meaning of marking. And after the marking, specific words are marked here. Now, if you consider this example, the marked word, the first four letters are marked, so they are hidden, and then the model predicts the word that what we are trying to say. So this is the way which word predicts the word that are marked and all the words surrounding the unmarked word. Now, before word, models read text left to right or right to left like GPT or RNN, but BERT read both ways at once, and that is called the bidirectional learning. So the bidirectional is involved here as we read from both ways at once, and that is why we called it as bidirectional learning also. Now this allows BERT to weigh the importance of different words in a sentence when trying to understand a specific word or predict mark one. Whenever we try to learn from both directions, we understand the importance of each word in a if we are considering a special word, and by this we can understand the or weigh the importance, or we can add the importance to the specific word regarding to the context word or the surrounding word in the sentences. And we can also predict the mark one if a particular word is marked, then we can also predict it. So this is the working or basically how BERT learns. Now example, if a sentence is the bank can guarantee your savings. Now BERT understands whether bank means money bank or river bank. So whenever we consider the word bank, we have two words in two meanings in mind. One is the money bank, and another one is the river bank. So understanding that what this bank specifically says, the bank can guarantee your savings is the example. So looking at the both sides, it understands that the bank we are talking about is money bank. So this is the working or the way it learns from a particular sentence. Now the need for BERT variant, we can also see the working. Now in this case, BERT is trained generally with the two main tasks. First one is the mass language modeling, that is the MLM, and second one is the next sentence prediction. So in mass language modeling, random words are replaced with marks, and BERT tries to predict the missing word using the context. Now, for example, we have the cat sat on the, and we have marked the word, the last one, and then the BERT will train. BERT will basically predict that the word we are trying to say is map. So this is the marked language modeling, and second one is the next sentence prediction, which given two sentences, BERT predicts if the second one logically follows the first. So that is the working also we can consider of the BERT. Now after this, we have the need for BERT variant. Now the original BERT, while powerful, it is resource intensive. That is, it is a large size and high computational cost is involved when you talk about the original BERT. But if our task is more simpler and we do not need such large parameters or large size, and our cost consideration is also low at that point of time, we need different variants of the BERT. So for that part, the different variants of the BERT were emerged to address specific needs like improving performance, increasing efficiency, that is the size of space, or specializing for particular tasks. Now, if we see the working of the or how does the BERT learn? Now it reads basically billions of sentences from Wikipedia, books, etc., and it learns relationship between words, grammar, and meaning. And for fine-tune later for tasks like question answering and text classification or sentiment analysis. The original BERT is very large and slow. You should all remember this. It's powerful, but it is not optimized for speed, smaller devices, and special tasks. So variants were created to fix these issues, and faster, smaller, and smarter versions of the BERT variants were introduced. This is one by one. The first one is RoBERTa, and we can say it was developed by Facebook, and it stands for robustly optimized BERT. aim for maximum performance by training but longer on larger datasets with larger mini batches and using dynamic masking. So RoBERTa was trained and it was trained from the as compared to the original BERT model, it was trained on larger data set with larger mini batches and it uses dynamic masking. Now for it removed the next sentence prediction. Whatever the next sentence prediction we had discussed here, the two main components are the training of the BERT variant, the original one, which was there on the mask language modeling and the next sentence prediction. The next sentence prediction is removed from the RoBERTa and it is trained on more time, longer time. So it often achieves higher accuracy by optimizing hyperparameters and removing the next sentence prediction task. And it is we can say that it is more faster and more accurate than BERT. So this is RoBERTa. I will see about the Albert. Now it was developed by Google and Toyota Research, and it is a light BERT for efficiency, and it stands for a light BERT. We can also say Albert or we can also say a light BERT. Now it reduces model size and speeds up training primarily through cross-layer parameter sharing. That is the reusing setting across layer. It uses parameter sharing to reduce the model size. Here we are trying to reduce the model size, and it is very memory efficient and works well in big NLP tasks. It also employs factorized embedding parameterization to significantly cut down parameters needed for word representation. We can also say it is a smaller but stronger version, and that is the Albert. Now next is the DistilBERT and TinyBERT. We can say it has a linear and faster also. It was introduced by Hugging Face, and these are very small, faster versions created using knowledge distillation, where a larger, that is the original one, the teacher BERT model trains a smaller student model. So this is the working. The larger BERT model trains a smaller student model. Now it is a compressed version of BERT. It is 60% smaller, 60% smaller, and 97% gives performance as compared to the BERT version. They retain a high percentage of the original BERT performance with significantly fewer parameters and faster inference time. So generally, if it is smaller, 60% smaller, the computational cost will be also less, and the performance will be not drastically reduced as compared to the size. If we are reducing 60% smaller, but it is still trying to retain the 97% accuracy as compared to the original BERT model. So it is good for real-time apps and mobile. So that are the use cases. Moving on. Uh, about the TinyBERT, we can also say it is an even smaller version of BERT, and it is ideal for embedded systems and edge devices. It is super lightweight, we can say, for the TinyBERT. Now we have the Electra, which is introduced by Google, and it is efficient pre-training. It uses replace token detection (RTD) task a small generator network layer replaces some input tokens with plausible alternatives. It is a new training method and it replaces token instead of masking them. Previously, we are masking the token, but here we are not masking. We are trying to replace it, and by that, it can become more efficient and learn faster. Now, the main discriminator Electra model that then learns by identifying which tokens in the interference were replaced, making it more sample efficient. Now, it trains like a discriminator, like it finds fake word, not the generator. It finds fake word, and it is much faster and high performing. So this is the Electra one. The next is XLNet by Google and CMU. Now, it is a permutation language modeling which captures the bidirectional context using permutation language modeling, training the model to predict words in all possible separate order of a sentence. It improves on word by permuting word order during training, and there is no masking here. It is all combination of a sentence, and it is better for long context or long text and context heavy tasks. It integrates the integrate technique from transform of Excel to better handle long term dependencies in text. So whenever the long texts are involved, we generally use the XLNet, and it generally remembers the whole conversation in case of long sentence. Now the next one is the span BERT and BERT sum. Now the Excel at predicting continuous spans of text, example for question answering by marking and predicting entire segment. So it improves BERT's understanding of phrases and span, not just words, and it is better at question answering or yeah, well, better for question answering, and it is fine-tuned especially for text summarization, modifying BERT's input to distinguish sentence and learn summary representation. It generally enhances the phrase level understanding. If much phrases are involved here in our data, then we should always go for the span BERT. And the next one is the BERT sum, which is the version of BERT used for text summarization. This is the text summarization part, and it adds special tokens to help model focus on important sentences. It is great for extractive summarization. When summarization will be involved, we use the BERT sum, and yeah. So these are the span BERT and BERT sum. Now we'll move towards the. I hope you guys understood the presentation of the slide on the BERT variant. Now we'll move towards the implementation part. Now, before starting the implementation part, we'll summarize the different models of the BERT we studied and also the BERT one. So starting with the BERT, BERT is bidirectional text understanding. So we'll bidirectional text understanding. Second one is the RoBERTa, right? RoBERTa, which is basically for if we have more data and we there is no NSP, that is the next sentence prediction here, and it has better accuracy. Third one is Albert. So let's see. Now it is smaller memory usage, smaller memory usage. Next is DistilBERT, which is the lightweight and the faster inference. Light, lightweight and faster inference. Then we have the TinyBERT, which is ultra small, ultra small, and for edge devices. Then we have the Electra, which is efficient training with replacement. Replacement. Then we have the ExcelNet, which is the permutation training for the long contextual words or the sentences. So permutation training for long context. Then we have the PanBERT, which is the pan-based learning, when the phrases are more. And then we have the BERT, that is the text summarization task. So these are the different variants. Now we will see the implementation part. First of all, we need to uninstall the Hugging Face, transformers and dataset. So for that, we will use pip install transformer dataset. Second, we will import the libraries. So from transformer, we will import pipeline, and we will import torque. Next, we will use pretend BERT for sentiment analysis. So pretend BERT for sentiment analysis. We'll name it as BERT classifier. We'll discuss pipeline. We'll mention the task here. Our task is sentiment analysis. Sentiment analysis. Then we'll mention the model name. Model equal to, that is the NLP town. NLP town. BERT base. Then multilingual. This is the model name basically. Multilingual. Lingual. Okay. And then the uncased sentiment. Uncased sentiment. We'll see the result equal to BERT classifier. BERT classifier, and we'll mention the classification sentence here. We'll type, I really love how easy how easy it is to use bird model, with Hugging Face. Hugging Face, question mark, and we'll print the result. So, it has given the sentiment, it has given 5 star, and we have got the score 0 point. That is 86%. So, this is how we can use a pretend bird model for sentiment analysis. Now, we'll see, we'll try another bird variant. We'll try for DistilBERT, okay? DistilBERT. We'll name it as the Distil classifier. Classifier, initial the pipeline. Task will be the same, sentiment analysis, and we'll mention the model DistilBERT, and it will be based uncased, fine tune, and then it will be SST to English. English. Okay. And next will be the text for the sentiment. So result is equal to distilled classify, and after that will be this movie. Okay, this movie was absolutely fantastic. Okay, fantastic and heartwarming. Okay, and we'll print the result. We'll see what it is showing. Loading in the model now. Okay, it is showing that the label is positive, and we got the score as 99%. So we have got a positive sentiment for this text. So it is, as we have involved the word fantastic and heartwarming. These generally are positive words, so it gave the positive label. Now next we'll go with the RoBERTa. Okay, let's try RoBERTa. RoBERTa, and we'll mention RoBERTa classifier equal to pipeline sentiment analysis, and model name will be Cardiff NLP Twitter. This is the model name, RoBERTa Date Sentiment. RoBERTa Date Sentiment. Okay, and RoBERTa classifier, and we'll give a sentence. I'm not sure. I'm not sure if I like this. If I like the service service today, right? And we'll print the result. So it is showing level 0. So that is showing that 86%. So this is the RoBERTa one for we can use for text classification. Now we'll use another use case for like question answering. Okay, question answering QA, that is the question answering, and using Bert. So for that we need to get the QA pipeline and pipeline. We'll mention the top here, question answering. We'll mention the model name. That is a Bert large uncaped. Bert large uncaped, and whole word marking Fine to call. Fine to call. Then we'll mention the context which will pass to the model, and using this context, we'll ask the question and it should answer according to the answer present in the context. So we'll give a sentence. Bert is a model developed by uh, Google to understand the meaning of language more effectively. More effectively. Okay. And my question will be, who developed the word? Bert. Who developed Bert? Now my answer will be QA pipeline, and I'll mention the question as question equal to question and context equal to context. Okay. I'll bring question to the for the question here, and for answer I mention answer and out. Okay. So it has answered who developed Bert, and we got the answer. So it is working quite good. Now we'll see the last one, TinyBERT. TinyBERT. TinyBERT pipeline mention the sentiment analysis and model, yeah, that is visual. Okay. And one Bert tiny, right? We'll mention that result TinyBERT, and we'll mention the sentence for sentiment analysis. My sentence will be the new product is amazing and very easy to use. And I'll print my result. So as it is a small model, I did not able to. So we will not get the better results when we use the TinyBERT model, as it is very small model. And as you can see, as you have found that it took very less time to download the model. Generally, these are not good for much complex tasks or any task in the production level. So this was the part where we tried to see and use the different versions of the BERT. We saw the TinyBERT. We used BERT for the question answering. It was good as it was powerful one. And we used the RoBERTa. Here we included the share. For this one, we'll do I like the service. So it is giving a positive sentiment here now, 97%. And we also saw that it's still but it was also working good. It was able to identify the sentiment and it was positive as the word fantastic and heartwarming were present, which are the positive sentiment word. We also saw the original bird version. Also gave good result. It was labeling 5 star and we have got 86% was a 5 star. Basically, we are including the positive sentiment here. I really love. So love is a sentiment where it is positive. How is it easy? Also is the one to it is used to use but model easy with Hugging. So this was the implementation part of the but and its type. So hope you guys understood the video, and if you did understand it, please like and subscribe our channel, and we'll meet in the next section. Till then. Bye.